Hello, welcome to my YouTube channel. So today we have a question on waves, which reads figure 5.1 and figure 5.2 show the displacements distance and the displacement time graphs respectively. The graphs are for a water wave in a ripple tank. So we have this one here which has displacement and what? Distance. Then we also have this one here which has displacement and time. So now the question here is saying state the wavelength of the wave. So want to find what? Wavelength. Want to find wavelength. So for you to find wavelength, you check, since we have two diagrams here. We have this here and this. And now want to find what? Wavelength. So understand the meaning of wavelength. So by definition, wavelength you say is the minimum distance at which the wave repeats itself. Meaning, come here now, where we have the waveform here. So since we are saying wavelength is the what? Minimum distance at which the wave repeats itself. So meaning from here up to here. So it's here, from here up to here, because the wave is about to repeat itself from here up to here. So it's about to repeat here. So meaning what you do here, you just get a distance from here up to here. So the number which is here, that's the what? Wavelength, because we have distance. From here up to here. So this is your what? Wavelength, which is 2. So the units, we have it here as what? Centimeters. So you say 2 centimeters. The reason why we are using this diagram instead of this, because here you have distance and here you have what? Time. So you can't get wavelength here because you have what? Time there. So no wonder we are focusing on the first diagram. So meaning wavelength is from here up to here, which is 2 centimeters. So wavelength, we use this symbol for wavelength, which is lambda. So this is your wavelength here. That's the answer for the first one. If you are not okay, with this method, you can also do it like this, where you get the total distance. So the total distance here is what? 3. Yeah? Then over, count now the number of waves. So the number of waves, we have 1.5. So meaning here we have what? 1.5. Then 1.5 into 3, what do you have? 2 centimeters, which is still the same. But now be careful with the first method. First method, yes, we said wavelength is the what? Minimum distance at which the wave repeats itself. So meaning from here up to here, we got what? 2. It's not always that you have to be getting the number here. You have to check first the first number. So if the first number is 0 and the final number here is 2, meaning you just get 2 because the first number is what? 0. In case you are the number here, then now there is also a number here. Subtract the 2 to get a what? Wavelength. Or you can also get wavelength from here up to here, meaning from 1 up to what? 3. Now you can't get 3. The reason, because we have to start on what? 1. So if you have 1 here, or a number here, and a number here, for you to get a wavelength, you say 3 minus what? 1. That will be what? Wavelength. Okay. Next now is what? B. State the period of the what? Wave. Period of the wave. So period, we use capital T. Now period, by definition, period, you say time taken for a complete what? Wave. So time taken for a complete wave, now check. You don't have time, then you have time here. So if you have time here, then you use this now to find what? Period. So check, since we are saying period, it's a time taken for a complete wave. Where we have a complete wave is here, from here up to here. From 0 up to what? 0.04. So meaning your period will be what? 0.04 seconds. Because we have seconds there. Again, if you have a number here, you are not supposed to get a number which you get here at a complete wave. No, you subtract the two. For instance, here we have 0.02. In the complete wave, it's up to here. Then now here we have 0.02. Then here we have 0.06. So meaning you can't get what? 0.06, no. Because we had to start on what? 0.02. So what you do, you just say 0.06 minus 0.02. Then you have what? 0.06 minus 0.02. You still get the same, 0.4 seconds, which is the same. Okay, so next now it's C. C, the question is saying, what is the speed of the water wave? Speed of the water wave. So to calculate speed, you use the formula for speed or velocity equals to frequency times lambda, or lambda times frequency is the same. So check here. We have frequency here. Then frequency, we don't have frequency here. So meaning you calculate frequency. So to calculate frequency, you use the formula for frequency, which is frequency is equals to 1 over what? Period. So we have 1 here over period. Period is what? We calculated period on what? Question B, 0.04. So here now you divide 1 divided by 0.04, what do you have? Okay, it's okay, you can use the calculator. Then 1 times the 100, you have 100. Over 0.04 times 100, you have 4. Then 4 into 10, you have what? 2. 4 into 20, you have what? 5. So meaning we have frequency, which is what? 25. So where is this here? You put what? 25. Times the lambda. Lambda now is what? Wavelength. Wavelength, we calculated wavelength as what? 2. So here now you say 25 times 2, you have what? 50. Now be careful now with the units. Be careful with the units. Since it's speed, normally it's supposed to be meter per second. So now since here our wavelength was what? Centimeter. So you won't say meter, but you say what? Centimeter slash second now. So this is your answer here. Again, if you're not okay with this method, you can also do it like this. You can also do it like this, where you say speed is equals to distance over what? Time. So distance now will be wavelength, which is what? Wavelength was what? 2 centimeters over time. Time will be what? Period. So period was what? 0.04. Then what you do here now, you just divide 0.04 into what? 2. So now here you just multiply 100 and 100 here. So 2 times 100, you have what? 200 over 0.04 times 100, you have what? 4. 4 into 20, you have what? 5. 4 into 0, 0. Then check, the units there was what? Centimeters. Then here period was what? Seconds. So this is your answer. If the question commands you to find speed in meter per second, meaning it was just a matter of converting 2 centimeters to what? Meters. When you convert 2 centimeters to meters, then it's the one you use here. Then now you have meter what? Per second. So that's the end. So just be careful with the questions on waves. Usually it's either they will give you this kind, just this question, which has distance here, then just expect a question to be calculate what? Wavelength. Then if you have time there, then the question will come as calculate what? Period. So understand the two diagrams. When you have distance, use it to calculate wavelength. When you have time, use it to calculate what? Period. Done.